Today I'm going to try to duplicate this piece here that I forged a few days ago. This is 1/3 of a mechanism called a Lewis. Now this started out as 1.5 by 1/4 inch bar, and I guess the proper term was I performed an accordion weld according to Roy at Christ-Centered Ironworks. Spit it out, Bill. Now right now it's right at 1.25 inches, or excuse me, 1.125 inches at the bottom. It's come down to close to 1.25 inches thick. It is right at 5.5 inches long. And the biggest problem with this is I need to make another one just like it, or really close to it. And I was pretty much testing to see if I could make this to begin with, and it come out just fine. There's one little bitty seam right there that you can see, but for sure that's not gonna hurt the integrity of the piece, as it lifts up like this. So I did not take any measurements on any of my bends that I made on this. I just bent it to what I thought it should be. So that's going to be a little bit of a problem. I'm going to have to try to remember, and I'm old and don't do that very well anymore, remember what I did to make this one. But that's what I'm going to try to do. So let's get a fire going and see what kind of diamond we can make. Let's talk some temperatures while this is getting up to heat. Now, the scale forms and adheres to steel at about a point of 1420 degrees Fahrenheit. I'm reading this off of a chart that I printed out to take to demonstrations with me. For people that ask the question, how hot is that? It's got heat colors and temperatures and different information on it. Borax melts at around 1365. Mild steel forging temperature and forge welding heat maximum is around 2300 degrees. The scale falls off of freely at about 1800 degrees. Now that's not the temperature the scale melts, but that's the temperature that it falls off freely, and you can see that especially when you put a twist on something. I don't know if that information will do you any good, but it's information. Now let's get this up to a welding temperature. Let's see if we can make our first weld. The color of my fire tells me that I'm approaching the temperature in which the borax is burning off. It's got a real bright orange color to it. The steel's coming up close to temperature. That fire will start turning a green color when it is. As the steel starts to disappear in the fire, or the color of it is close to the color of the fire, I also know that that's about the temperature. And I'll also be able to see that the steel sweating. Sparks is not good. Sparks when you hit it's okay. You're going to get some of that flying out as that molten steel shoves its way out. Hopefully some of that flux will get shoved out. It'll shove the iron oxides out with it, scale. However cool this looks to a blacksmith, this forge welding, I don't think it's a real good thing to demonstrate in public. Number one, you get flying hot metal all over the place. And number two, you spend an awful lot of time with it in the fire watching it get hot. People get bored and move on. Here we go. Pretty sure we got a weld there. Now I'm guessing. I'm just going to come up about that far. Put a bend in it. Well, we're getting real close to temperature on weld number 2. Sprinkle on some magic pixie dust here. Also, looking at that steel, I had reached a welding temperature. So I need to make one more bend. What appears to be about 1.5 inches. Yep. Up that there. Once again, I'll bend that at the vise. Well, I'm going to go ahead and cut this off the parent stock now. need another heat. Well, I don't know if you can see it on there or not, but I pretty much got that all blended in down there. A little bit of a telltale seam there, but I'm really not that worried about it. Now I think I'll turn this around. Let me see what we got for thickness here. I'm guessing it's real close to what we want. On the end, yeah, it's just about 1 1/16. We don't want it much thinner than that. So I'll work it, tapering this seam here out a little bit more. Need to blend that weld in there a little bit. A little bit more of a whole lot what we've been doing. Well, you didn't miss a whole lot. Whole lot of forging. Whole lot of smoothing out. A little bit of brushing. Had to cut it off, which I figured I would. I thought it was a little bit too long. Now, it's not exactly the same size as the other one, but it had to be a little bit smaller at this taper, and it's a little bit thicker at this end, but that does not matter. Now, it's still hot. I'll see. Okay, here's the old one in its place. This hole in this stone, I don't think you can see it, but it's tapered. It's whiter at the bottom than it is at the top. So this wedge fits in there like that. Then this wedge, you don't want it, you want it just wide enough where it will fit in there, but snugly, and it slides down in and then forms that gap in the middle. I'll just use my my measuring stick here to demonstrate. So a piece probably just about 1/4 inch wide will slide down in between there. I'll punch a hole in all 3 of these. A pin will go through with a clevis over the top. That way that stone can be lifted, set in place without straps being around it, or without marking the edge with some kind of a pickup tool. And that's the idea of the Lewis. So that's real close to 1/4 of an inch. I've got a piece of flat stock left over from making this one that I think I can forge. It'll go right down in there. We shall see.